Hello guys, today we are going to discuss about Docker concept. Why Docker is required. Is it traditionally our system like what we were using in the past is a physical services concept. There was concept of the physical system service. Let's take an example. Physical server. Over that you have OS operating system and over this you are deploying your application server. So this was traditionally we were following. So just taking an example here, you have 16 GB RAM and let's say you have 8 core CPU. Okay. This physical server concept, what was the problem? I'm just taking an example that your physical server is 16 GB RAM and having 8 core CPUs. The problem in this is that let's say your application, whatever the application you have deployed here, let's say you have deployed Tomcat and let's say you install Flipkart end user .war file, Flipkart customer care .war file. Okay, so let's say you install this. So Tomcat is a deployment server. You install two applications, Flipkart end user and a Flipkart customer care. What are the problems with the physical server? This physical server, let's say it is using 8 GB RAM and my 4 GB RAM is not utilized, free, right? The problem is this, my resources are getting wasted. There is a one problem. This is another problem. You have deployed your both the applications, end user and the customer care, on your physical server. So let's say a Flipkart is doing a maintenance for the customer care application. Will it be able to afford a downtime for the end user? It would be a huge business loss, right? They cannot do it. Then the people, if you heard about AWS, EC2 is on the physical server or on the virtual server, on some, like it is on the virtual machine on some physical server. So AWS EC2 concept is of virtual server on some physical server. So there is a concept called virtualization came, not because of the AWS. I'm just giving an example of AWS, but because of all these issues of the physical servers, a virtual server concept or virtualization concept came. So let's discuss about what is virtualization. Here again, you need an infrastructure, right? You need an infrastructure here of your physical server, and let's say it is also of same configuration. Okay, and over that, in the virtual server you need a layer which is called hypervisor. So uh, hypervisor. So what are the famous hypervisors? In Windows we have Hyper-V, we have VMware, which is very famous, we have Oracle Virtual Box, and Amazon is using Citrix Zen. So they are also using a virtual layer. This is my virtual layer, and they are using a virtual layer over this. So this is my hypervisor is a it's provide the infrastructure for virtualization. So over this you can create lots of, I would say, virtual service. I'm just extending, you can get a better view. Lots of virtual service. Each virtual server, this is VM, this is my VM, and each virtual server is having its own OS. Let's say you install Windows here. You have to deploy your application. Let's say here you install your end Flipkart end user application. Okay. Here, let's say you have Red Hat OS, and here you install customer care, Warfight, like I mean to say the application. Let's say here you have CentOS OS, and you deploy it for the database. So, and here you, let's say you allocate, I would say 8 GB RAM. Here I allocate, let's say 2 GB, and here I allocate 2 GB RAM, and respectively the cores, 8 cores you have divided here, so that the problem and the positive part. The positive part, what the problem I was having in my physical server is that whenever I'm trying to bring down my application, it will affect both end user and the customer care. In this, the problem is resolved. If my end user is having an issue, or I have to deploy a new application for customer care, then my end user will not be impacted the same as my customer care. It split the physical servers in different virtual machines. For example, a laptop. In laptop you have a Windows OS. You can install n number of virtual machines. Depends upon your hardware capacity. You can install n number of virtual machines. You can install Windows, you can install Linux, you can install Ubuntu, any OS, and respective applications on your laptop. So the same concept, it split the physical servers. So the positive part again, that one VM is not impacting another VM. So that's my problem is resolved. Now the bigger question is here. Are you wasting your physical resources? Yes, I'm wasting, right? How? My my issue is here, my 4 GB is being used, let's say 8 GB being used and 4 GB is free. After virtualization, let's say 8 GB, here my only 4 GB is being utilized, 4 GB is not in use. My one problem is resolved, that my end user will not be impacted customer care, but my issue of resource sharing is still not resolved. So and the VM, another bigger issue is that the VM is VM is about uh, the and about VM, it's a heavyweight. VM is heavy weight. So when about talking about the heavyweight, heavyweight, it means that it we have to install OS. When we install OS, obviously the resources required for the OS is like the CPUs, the RAM is required for the VM to run, obviously on the very costly, means the resources perspective. So that's why it's called the VM is a heavyweight. And system resources in VM is not shared. The system resources, let's say my 8 GB RAM, my system resources are not shared. When you talk about the uh, resources, once you install the VM and configure the VM, the resources will not be free. The resources will not be free. So resources will not be free. So my 8 GB, you can allocate your 8 GB RAM to another VM, but you need a downtime required. You can you can allocate to another VM. That's absolutely possible, but you need a downtime here. You need a downtime and then allocate 4 GB here, and vice versa. You can do it. But the problem is that one is that starting and stopping. You can, for reducing and increasing the capacity, you need a downtime. Allocation of the resources, you need a downtime, and this create lots of issue. And another issue which I want to highlight, in configuring the VM, you need to install here, let's say a deployment server Tomcat. Here you need to install the Tomcat, the respective dependencies you have to install. So each server, my point is each server you need to deploy application and respective dependencies. So you have to this is one of the bigger problem, right? You have to install the dependencies, you have to install the applications. So the problem is that means each and every time in each I would say allocation, you have to deploy it your so I mean to say you need to deploy application respective dependencies in each and every VM. So another problem in this is a reboot time, because each and every VM do have the OS resources. Then the downtime would be like it's more downtime, because when OS is involved, it stop all the resources, and when you start, it need to start all the resources. That is a bigger issue in the VM. So for resolving this issue, we have a concept of Docker. What is a Docker? A Docker is a containerization platform which package your app from all dependencies together in the form of container. So here, like container, you know the concept of the container, right? The containers are just like you can build. Here you can see, right, you build your container and can move from one location to another without any issues. And and it is an open platform, and it's for developers and all, it's good enough. But here you can build, you can ship, you can run in a distributed applications. You will understand this. So till now we discussed about the physical server and the virtual server concept. Now we need to discuss about the virtual server and the Docker. Docker is a container platform. When we are saying a container, you can install multiple containers. C1, C2, multiple containers you can deploy on a virtual machine or a physical server. So let's understand how does a Docker say. So here you need when I was showing here you the virtual, you can create a Docker containers on the virtual box. The reason behind is here on physical server, physical machine or the virtual machine, you need a software which is very popularly known as Docker here. Docker. So over the VM or the virtual machine, physical machine or the virtual machine, you can have a Docker. Here you should be having host operating system. Obviously virtual machine cannot exist without anything, so you need a host operating system. Over that you need a Docker. So what is the benefit of having a Docker? Here, after having a Docker, you can have multiple containers. Let's say here, right? Docker is known as a containerization software because it's package your application in the form of containers. So there is a containers. The positive part of the container is that once you deploy your container, it's portable. Portable means you can apply the same application plus dependencies on the dev, UAT and prod. You don't need to deploy application and again, because here application plus dependencies, let's say for a Java you need to install, right? So Tomcat you need to install, you need a dependency of Java. So once you install in one of the container, here you can do it from on the virtual machine or you can do it on the physical machine. You can deploy your containers, and here the same container you can deploy once you, like, let's say you install the first container, the same container you can deploy in, let's say you have the prod or UAT, same application and dependencies will be installed. So the worry part of every installation in different environments can fail of different reasons, not possible. Once the application and dependencies are installed and configured and stored in a Docker, we will understand what is Docker repository, but you need to understand containers. It is having a container which is an application and dependencies. So the isolation has been applied, the positive part. Now the positive part is that the isolation is at the OS layer, right? This OS here I have to install the OS in each VM, but here my OS is common. My OS is shared. And another positive part is that each container is having the application and its dependencies. So hypervisor is creating a virtualization on your physical server. This is a virtualization on the hardware level. When I were talking about it, is here we are talking about the hardware virtualization. Okay, it's a hardware virtualization, but here we are doing OS level isolation, or the Docker is a OS level, is a this is a hardware operating system. Once the operating system will be installed here, you can have multiple containers over that, and it is shared over this. Dockers, here we can understand better. So here your host OS is there, server is there, and Docker daemon is running. And here you bring your application plus binaries A, B, and C. It will be shared on the host OS, where hypervisor is shared, and you have to create your OS separately over that. This is a bigger problem because OS are the heavyweight, whereas when OS is shared among different containers, it becomes very lightweight. So my another point is Dockers are lightweight. So Dockers are the lightweight. It consumes less system resources. The reason behind it does not have the OS. OS has been shared. So let's say you need to you need an application with a 3 VM is good enough, or having a 1 VM. Obviously there's a virtual machine, 1 VM having the 3 containers. Obviously that is better because your hardware resources, let's say a 16 GB RAM will be your this is hardware operating system, it is having the CPU and your RAM, it is being shared. And if my first container is having a problem here, if my first container is having a problem here, my application, let's say here end user, Flipkart end user is being installed here, customer care is installed, my customer care application will not be impacted with my end user application. And the another positive part is that once this application is being acted as a container, you can deploy this container image. This is an image application plus binaries, the dependencies. You can copy this image, or I would say copy is the wrong word, but you can deploy this image as a container as service on any other platform. Means this is just like a image you can copy, and that's why it's called a portable. So does not require the guest OS as it share host between the containers, does not require a hypervisor. It does not require hypervisor. Hypervisor is used for the physical server virtualization. It does not require. Docker contains packages, are self-contained and can run application in any environment. So these Dockers are the self-contained. When you say self-contained, it is having the, let's say, Tomcat, which is dependency Java, because Java is needed for the running Tomcat, right? It will bring that dependency along with the package, application package, like war file, Flipkart war end user.war, or the customer care.war. It will bring that, it will create that package it will create that image which can be used. It is using the when you're talking about the containers here, it is using the host OS kernel. Kernel is a heart of everything. Means what is kernel? Kernel is a kernel is having your system resources, right? Is allocating your depends on your requirement. It is allocating the system resources. So it is sharing your kernel. Here kernel has been not been shared because each VM is having its own um, operating system, and operating system do have their own kernel. So these are not being shared, whereas here kernel is being shared, your resources is being shared. I hope you understood the concept from physical server to the virtual server. This is a virtualization where hardware virtualization is there. Here we are using operating system virtualization. This is a concept of the topic. So in next one, I will be covering about the commands, and we will be discussing about how we can install Docker, how can we deploy the Docker as images as a container, and application can use container as service. Thanks a lot for viewing my channel. Thank you.